Hey students, welcome back. So let us begin with a very important chapter in your chemistry, and that is your sulfuric acid. Why is it so important? Because it is there everywhere. It is a very strong oxidizing agent. It's a very strong dehydrating agent. You see it in electrolysis, as an electrolyte, and so many places, right? So let's see how is the preparation and how are the different reactions of sulfuric acid. So let's start with the preparation. We begin by the contact process, which begins by taking sulfur. Okay, sulfur or the pyrite burners. So what happens? Sulfur reacts with your oxygen. Okay, so you burn sulfur and you form what? Sulfur dioxide, SO2. Then in pyrite burners, you use FeS, iron sulfide, and in presence of oxygen, okay, what you get? Iron oxide, FeO, plus what? Your SO2. Now the next process, what is there? The next step that is there, that is in contact tower. What happens basically? This SO2 gas which is there, okay, it reacts with oxygen in presence of vanadium pentoxide, V2O5, in presence of the catalyst V2O5. And what is the temperature and pressure is important? 450 to 500 degrees Celsius at 1 or 2 atmospheres. This is the pressure, 1 or 2 atmospheres. And what will be formed? This is very important in the formation of sulfuric acid. Basically we want this, okay, SO3 plus a lot of heat will be formed. Now let's see what happens. Continuing the contact process, in the absorption tower, this SO3 plus H2SO4 will give me what? H2S2O7. Remember this compound, H2S2O7. And what happens in the dilution tower? H2S2O7 plus H2O will give me what? H2SO4, 2 molecules of H2SO4. So this is how, with the help of the contact process, we prepare the sulfuric acid. So since this SO3 which is produced is highly reactive, it gets absorbed in different sections of the tower. Okay, in the absorption tower what happens? Oleum is formed. Okay, this compound is the oleum. Dilution tower, what happens to this oleum? It reacts with water and form the sulfuric acid. Okay, let's move on to the acidic nature of sulfuric acid. Okay, so your H2SO4 reacts with water to form hydronium ions. Okay, now that is the acidic nature, right? Any acid that dissolves in water and form what? Strong acids form the hydronium ions and your sulfate ions. This proves the acidic nature of your sulfuric acid. Yes. Reactions of dilute sulfuric acid. Let's see. Zinc plus H2SO4. Let's see how it reacts. It will give me ZnSO4, your single displacement reaction if you remember, plus H2. Okay, this was your reactions of dilute sulfuric acid with your metal. Let's take another metal, iron. Same, single displacement reaction will occur. Iron will react with SO4 to form FeSO4 and H2 gas will be liberated. Clear? Then using sodium hydroxide, so we have a base here and an acid to form what? Salt and water. What is this base? Na2O, sodium oxide. H2SO4 will give me Na2SO4 plus H2O. Reaction with the base. Reaction with another metal oxide. Okay, MgO base. H2SO4 will give me MgSO4 plus H2O. A double displacement reaction, correct? Next, ZnO plus H2SO4 will give me ZnSO4 plus H2O. Okay, let's move on. Copper oxide, another metal oxide, then H2SO4 will give me CuSO4 plus H2O. NaOH, your sodium hydroxide now we are using, not oxide, now we are using metal hydroxides. Metal hydroxide will react with your sulfuric acid to form what? The salt, same salt but this time H2O, 2 molecules. We saw this reaction earlier as well in earlier chapters, right? Previously. So ZnOH twice, zinc hydroxide reacts with H2SO4 to form zinc sulfate plus H2O. How many? 2 H2O. In oxides we get 1 H2O, hydroxides 2 H2O. Simple. Next, Na2CO3. In presence of carbonate, what is going to happen? Carbon dioxide gas will be released. We saw that earlier. So Na2CO3, so that will form Na2SO4, sodium sulfate plus your H2O plus your carbon dioxide gas, CO2. So one O is taken for H2O and this CO is liberated as CO2. Simple. Is that clear how carbonate reacts with sulfuric acid? Okay, sodium carbonate. Copper carbonate, let's take another metal carbonate, react with sulfuric acid, CuSO4, H2O and CO2 gas will be liberated. Clear? Okay. Next, KHCO3, that is your potassium hydrogen carbonate. Potassium hydrogen carbonate reacts with your sulfuric acid to form K2SO4. Okay, K2SO4, that is your potassium sulfate plus H2O plus CO2. Just the molecules, the number of molecules are changing. Clear? Okay. So let's continue with the reactions of H2SO4. So this time we are taking the salt Na2SO3, your sodium sulfite, reacting with your acid, sulfuric acid, and you are getting Na2SO4 plus H2O, and this time because SO3 is there, we are getting the gas SO2. SO2 gas will be liberated. Okay. Then sodium hydrogen sulfide, same salt, water molecule will increase and SO2 gas. Same reaction. So hydrogen sulfide you take or sodium sulfide you take. Clear? Okay, this is with the sulfide. Let's see the next one. We have sodium sulfide. Okay, this was sodium sulfide, this is sodium sulfide. Sodium sulfide reacts with your H2SO4, Na2S plus H2SO4 will give Na2SO4 plus H2S gas, simple H2S gas, hydrogen sulfide gas. Okay, ZnS, your zinc sulfide plus H2SO4 will give zinc sulfate plus H2S gas. See the liberation of hydrogen sulfide gas in these reactions. Okay, iron sulfide H2SO4 will give me FeSO4 plus H2S gas. So we saw the liberation of which gases? We saw the liberation of CO2 gas, we saw the liberation of SO2 gas, we saw the liberation of H2S gas. Okay, when your salts, different salts react with the acid H2SO4. Let's continue. So now we are going to see how your H2SO4 dissociates. Okay, as you know that it is used commonly as electrolytes. So let's see the dissociation of H2SO4. So first of all, we have to understand it dissociates into two steps. Number one step is H2SO4 dissociates to form H plus and HSO4 minus ions. Okay, so you take out one H at a time. Then second, you use the same HSO4 minus ions, which will dissociate to take out another H which is there and form the sulfate ion. So this is the two steps procedure here. Okay, so if we see, we have to cancel out this, right? We have to cancel this out, this and this. So what are we left with? H2SO4 will give me 2H plus plus SO4 2 minus. So this is the final step. Correct? So this is how your acid H2SO4 dissociates in two steps. It forms two types of salt. Okay, number one, sodium hydroxide. When it reacts with sodium hydroxide, see, to form a salt we have to make, if this is, we are talking about the acid, right, we have to make it react with a base in order to form a salt. So which base we are using? Sodium hydroxide base we are using. Okay, so which salt will be formed? Sodium and sulfate will come together, sodium hydrogen sulfate, NaHSO4. This is an acidic salt, okay, because you are using a strong acid here in order to form the salt. And what are we left with? H2O. Okay. Next, when we use excess of sodium hydroxide, you are increasing the base here. Okay, and react it with the same acid, you will form Na2SO4. Okay, this Na will come with this SO4. This is a normal salt, not an acidic salt, and you will form H2O here. Why normal salt? Because we are using excess of base here. See the reactions carefully. Okay, so NaOH excess will plus H2SO4 will give me Na2SO4, not NaHSO4, Na2SO4, which is a normal salt, plus H2O, 2H2O. Clear? Okay. Let's move on. Non-volatile acid. How do we form non-volatile acids from this H2SO4? So NaCl, we have to use NaCl here and use H2SO4 in the concentrated form. See the temperature
less than 200 degrees Celsius.
You get NaSO4 plus HCl, non-volatile gas. Next, you can use this HCl and more of concentrated H2SO4, and what you will get is KHSO4 plus HCl. Okay, again
less than 200 degrees Celsius.
Let's move on to another non-volatile gas, HNO3, how it will be formed. So we will change the salt simply. Instead of using Cl salt, that is a chloride salt, we will use the nitrate salt. So sodium nitrate salt and react it with H2SO4. Double displacement reaction will happen. Okay, NaSO4, NaHSO4, and what will happen? HNO3. So you got a non-volatile acid here. Okay, if you want to make the same with another compound, we can use potassium nitrate H2SO4. Okay, that will give you what? KHSO4, KHSO4 plus HNO3. Okay, again at
Less than
200 degrees Celsius, do not forget the temperature. Okay, now let's see how your sulfuric acid acts as a very strong oxidizing agent. So again we have a dissociation in 2 steps, very important. So let's see, just review it quickly. H2SO4 is giving what? H2O plus SO2 plus O, nascent oxygen, and this is why it is a very strong oxidizing agent. Can you see that? Okay, then let's take one metal, Cu plus O. Okay, Cu plus this O will give you what? CuO, copper oxide. So it has got oxidized. Can you see that? Okay, CuO and excess, like more of H2SO4 will give you copper sulfate plus H2O. So let's see the reaction. So we can cut this out, O and O. We can cut the CuO and CuO here. That is the only common thing, right? Then we are left with what? H2SO4 plus Cu. So your copper with the help of your sulfuric acid gets converted to your copper sulfate plus water H2O plus your SO2, liberation of the sulfur dioxide gas. And this is how it acts as a very strong oxidizing agent. Let's see the different reactions. So how it oxidizes carbon, see. So carbon, your coke, in presence of your concentrated H2SO4 sulfuric acid forms carbon dioxide. So see, oxygen is getting added to it plus your water plus SO2 gas. So this will be the common thing which we just saw. Okay, how it is formed. Next, sulfur, then it will be oxidized to sulfur dioxide, SO2 plus 2H2O. Okay, here already we have this sulfur dioxide gas, right? So we are not supposed to write this. Next, phosphorus. Let's see the metal, non-metal phosphorus. So H2SO4, in presence of H2SO4, what will happen? S3PO4. What is getting formed? Phosphoric acid. Phosphoric acid is getting formed, then H2O and your SO2 gas. Can you see the reaction? Yeah. Copper, H2SO4. What will be formed? Copper sulfate plus H2O plus SO2. So as you can see, it is a very strong oxidizing agent. It is oxidizing the non-metal as well as the metals. Okay, let's take another metal, zinc. In presence of concentrated H2SO4, what is getting formed? Zinc sulfate, H2O and sulfur dioxide. This is common. Correct? Yeah. Let's see how it acts as a very strong dehydrating agent. Okay, all the reactions which are there in this. So let's take glucose, C6H12O6. It dehydrates glucose. Dehydrating means taking out the water molecule from it. Okay, so what you are left with? You are literally left with carbon and it dehydrates it, removes the water molecule from the glucose molecule. And this happens in presence of concentrated H2SO4. So let's see the reaction. Reaction C6H12O6, presence of concentrated H2SO4 forms 6 carbon molecules plus H2O. C12H22O11, that is your sucrose molecule, in presence of concentrated H2SO4, H2O will be removed from it and you will be left with carbon. Okay, C6H10O5N, okay, there were n numbers of these molecules in presence of concentrated H2SO4, C, n number of carbon molecules and n number of water molecules. So all you get is water and carbon. See how strong dehydrating agent it is. Okay, copper sulfate plus 5H2O. So this will be taken out, the H2O molecule. So CuSO4 plus H2O. Simply what you have to use? Concentrated sulfuric acid, which acts as a strong dehydrating agent. So I hope all the properties, that is being a strong oxidizing agent, dehydrating agent, all the reactions which are involved in the same is clear to you. So revise the concept. Best of luck for your exams and thank you.